Hello class, so today is our video on Coulomb's law. So I want you to know what Coulomb's law is. I'll give you a definition, but mostly it's just understanding what the equation means and then being able to solve for the force with at least 3 charges being involved. So Coulomb's law can be formally stated as the electrical force between two charged objects is directly proportional to the product of the quantity of the charge on the objects and inversely proportional to the square of the separation distance between the two objects. So to break that down a little bit, the electrical force, that would be this, the electrical force between the two charged objects. This would be Q1 and Q2. Would be directly proportional to the product of the quantity of the charge, aka quantity 1, quantity 2, and inversely proportional, so this means these are multiplied. Anytime they say inversely proportional, that means they are dividing inversely proportional to the square of the separation distance, i.e. r squared. So divide by r squared. So to state this as a equation, it'd be Fe, the electrical force, is directly proportional. Anytime they say is, that's an equal sign. Is directly proportional to this Q1 times Q2 divided by the distance between them. And hopefully this looks familiar. This is the equation we've been using in class, but maybe you're like, wait, but something's missing. You're right. It's the K. Essentially, when you have constants, this is to make it work. What I mean by that is when they actually do the math in the experiment, they can actually test how big the charge is, how big the second charge is, how big the distance is, and how large the force is. And what they found is that it's always proportional, and then we get the exact same number if we multiply it by this number. So constants are from experimentation. So someone actually did this, hundreds of thousands of times, and discovered that this number makes the math work. Alright, now to actually do the math. Alright, so this is page 6. You can either do this in your notebook or in the packet. I don't care either way. So I'm going to do the first one just for you in case you need, and then I want you to do 8 on your own, and then I'll provide you with the answer. So we essentially always identify which one you want to have the force on. It has a picture drawn for you. So it says, for the picture below, find the force on Q1. So this, we're going to talk about everything in relation to this. And it is a positive charge, so let me know. Notice all of these are going to be a positive charge. So remember that when you're deciding direction. So Coulomb's law only does things with 2 charges, which means you can only do 2 charges at a time. So you have to do 2 separate equations. One for Q1 and Q2, over the square distance between them, and then the other for still Q1, because that's what we care about. Oh, and this is the R1, the distance between them, and Q3, this guy, over not just R2, but R1 plus R2 squared, because that's the entire distance between them. Alright, so now that you have an idea of that, really once you get those formulas, it's put it into a calculator and do the math. So remember, K is 9 times 10 to the 9th. Q1 is 5 times 10 to the negative 6. Q2 is 6 times 10 to the negative 6 over R1, which is 9.0 times 10 to the negative 10th squared. Plug that into a calculator. And if you plugged it in correctly, you should hopefully get, for the first one, 3.3, I'm only going to go that far, times 10 to the 17th. It's a really huge charge because they are very, very, very close together. And note that this force on this charge, which direction is it going to push it? It's going to push this particular charge to the left, because remember they're both positive, so that force is going to be repelling. Alright, then go to the other charge. So this one's a little more complicated, just because you have to add the R's together, because that distance is essentially not doubled, but extra because of that. So this is going to be, again, that 9 times 10 to the 9th for K, times Q1, which is still 5 times 10 to the negative 6. Oh, running out of room, times 4 times 10 to the negative 6. Made it. Divided by those two R's added. Since these are the same, you can actually just add them directly. So it'd be 9 plus 6, which hopefully you know is 15 times 10 to the negative 10th squared. If you weren't sure how to do this, you can always just put it into your calculator, and that is what your calculator will give you. So again, put this into your calculator, and then you're going to get 8 times 10 to the 16th. So again, large number, very short. Slightly smaller because the distance is larger and this charge is less. And then again, this is going to be a groupthink. Is this a repelling or attracting force? They're both positive, so again, this is going to be a repelling force. Since these are going the same direction, repelling away, you can just add them. So again, you can just plug those into your calculator and add them. Depending on how your calculator works, you might be able to go up and grab the previous answer and add it. That would make things in your life easier. If you add them, it's going to be 4.13 times 10 to the 17th. So a way to think about this is if you wanted to make this in the 10 to the 17th scale, this would be 0.8. So you essentially just added 0.8 to this. Slightly different because it was rounding, but that's why I don't need this. That's why this went to a 1 over here, 4.1 times 10 to the 17th. Alright, so hopefully that made some sense. Try the next one first. So try 8, and then come back for the answer. But do try it first. It's much harder to do it without me telling you exactly the steps. It's very easy listening to me explain why things happen and being like, of course. So try it first. Alright, maybe you noticed, maybe you didn't. This probably looks really, really similar because, hey, it's the same exact numbers. The only difference is we care not about Q1, but Q3. So you're going to essentially do the same thing, except with a focus on Q3. So you're going to want to do the force between Q2 and Q3 times K over their R2 squared, because that's the distance between them. And then you're also going to want to do the distance between that and Q1, so it'd be Q1 times Q3. Again, over, you have to add your distances. If you're not sure, you can look back at how I added distances. So again, now once you've figured out that, it's do the math. So this is, K is 9 times 10 to the 9th times Q1, which is 5 times 10 to the negative 6, And this is 4 times 10 to the negative 6 over, if you add those, it'd be 15 times 10 to the negative 10th squared. Alright, plug it into your calculator, and you would get 8 times 10 to the 16th. Alright, then do this one, which is, again, 9 times 10 to the 9th, that's a 9. Sorry about that. Times their Q2, which is 6.0 times 10 to the negative 6 times 4.0 times 10 to the negative 6 over, this is just one distance because it's only that far away, 6.0 times 10 to the negative 10th squared. Plug that into your calculator, and you get 6 times 10 to the 17th, and then think about which direction they're going. So this is Q3, so the force Q3 feels, these are all, again, positive. So for this force, it's getting pushed to the right, and since this one's also positive, it's getting extra pushed to the right. So you can just add these forces. If, for example, one was negative, you would subtract that force. Otherwise, add them up, and you get 6.8 times 10 to the 17th. Again, this should look kind of familiar because 0.8 times 10 to the 16th, or 0.8 times 10 to the 17th is the same thing. I just moved the decimal over one place. And since it was bigger before, this number goes up, and then you just add it. Ta-da! Alright, hopefully this was informative. We'll practice this tomorrow, as well as going on to remember that you should keep working on your report if you are not already done, or aka what's due today, for those of you who are watching, was the rough draft. So if you're like, wow, that was crap writing, great, we're going to revise it, which will also be worth a lot of points. So if you already got it in, great. If you didn't still get it in, I will still give you points for a late rough draft, but get it in as soon as possible. This week we'll find time to go and review your rough draft, so you have a chance to work on it, make it better, and return it in next week. Or this will be due, let's say, Saturday night. For real. Alright. Have a good evening. See you tomorrow.